Hi students, this is Miss Tomorrow and we're going to talk about infinite limits. So the first thing is we're going to examine the following functions as x approaches infinity. And actually in my first example we're using n. So it says what's the limit as n approaches infinity of n over n plus 1. Okay, so the first thing we want to do is take a look at the graph just to kind of see what happens. And then we're going to go over some of the rules. So I'm going to take a graph and we're going to use x. So x over x plus 1. Okay, so if I follow x to infinity, that means positive infinities to the right. If I follow the graph to the right, it flattens out. That's where the horizontal asymptote is. Let's take a look at the table. So if my x values keep getting bigger, what's happening to my y values? So I got 0.9. These are all 0.9s. They're getting bigger, but just little by little. So what number is it getting really close to? It looks like it's getting really close to 1. So I would say that this equals 1. Well, how did we get that? The highest power on the top is n to the first. The highest power on the bottom is n to the first. When I looked at the graph, it was a horizontal asymptote. We already talked about this in the beginning of the year. Remember, what's the rule? If the powers on top are the same, it's the coefficients. So n divided by n is 1. We used limits to infinity to find horizontal asymptotes. So that's where the rules came from in the beginning of the year. Let's try a few more examples. Okay, we're going to use the same technique. So let's look at number 2. Highest power on top is 2n. Highest power on the bottom is 3n. So since the powers are the same, it is the coefficients, which happens to be 2/3. Now, the reason we don't use the graph for every single question is reasons like this. It would be kind of hard on the graph to tell that it's exactly 2/3. So that's why we have the rules. Let's take a look at number 3. Highest power on the top, 6n to the third. Highest power on the bottom, 3n to the third. The powers are the same, so it should be the coefficient. So 6 divided by 3 is 2. Okay, let's take a look at a couple more. Now, if we look at this one, the highest power on the top is 2n to the fourth, but the highest power on the bottom is 6n to the fifth. So the powers are not the same. The highest power is on the bottom. Now, we did talk about this when we talked about asymptotes. So basically, wherever the highest power is, kind of wins. It's going to get bigger faster. So we're kind of going to ignore the top. If the highest power on the bottom got bigger and bigger, let's think about this. 1 over 100. Okay. Now I'm going to get the bottom even bigger. 1 over 1,000. 1 over 10,000. What are these numbers getting really close to? I mean, infinity is even bigger than this. So if I have a number on top and then infinity on the bottom, what number would that get close to? 0. So the bigger the number on the bottom when you have a fraction, the closer it is to 0. So remember, we talked about this when we did the horizontal asymptotes. When the highest power is on the bottom, it's going to go to 0. Now, number 5, let's look. Highest power on top, n to the fourth. Highest power on the bottom, 2n. Okay, so the highest power is on the top. Where is this going to go? So what we do in these cases is we look at this. The highest power on the top is n to the fourth. The highest power on the bottom is 2n. So obviously the top is going to win. The plus 1 on the bottom isn't going to really matter. If I were to cancel these out, I'd have n to the third over 2. If I were to cancel the n's. So the highest power on top is n to the third. That's like plugging infinity in and saying infinity to the third power. Well, infinity to the third power is basically infinity, right? Infinity is the biggest thing you can have. So that graph is going to go to infinity. So let's make some conclusions. Okay? First conclusion. When is the limit of a rational function equal to a constant? Remember, a constant is a number. Ooh. When the highest power in both the numerator and denominator are the same. So if the powers on top are the same, top and bottom are the same, remember, what do you get? It's the coefficients. That's what the limit is. Okay. When is the limit of a rational number equal to 0? When the highest power in the denominator is larger than the highest power in the numerator. So if the bottom is got the highest power, it's going to be a 0. And then the last one, when is the limit of a rational function equal to positive or negative infinity? If the highest power in the numerator is larger than the highest power in the denominator. Now, we haven't really talked about negative infinity yet, but we're going to in a little bit. First, I'm going to have you guys try the following. So take a look at these 3 examples. Either do them on your paper, or if you did the printout, do them right now. You can pause the video. We were going to go over the answers in class. And try these 3. Again, we'll go over the answers in class. So pause the video, try the questions, and we'll discuss in class. Now, let's discuss negative infinity. Okay. If the highest power is on the top, we're going to cancel the highest powers, and then we can see your answer is either going to be positive or negative infinity. Okay, so the other rules apply, the infinity rules. If the powers are the same, it's the coefficients. If the highest power is on the bottom, it's 0. But let's take a look. The highest power on top is 3x to the 4th, and the highest power on the bottom is x squared. So in other words, on top, the 3x to the 4th, if I plug any kind of an infinity or negative infinity in, it's going to grow a lot faster than these 2 numbers. So we can kind of ignore those. And same with the bottom. The x squared is the biggest one. So if I add an x and subtract a 3, it's not going to change the value that much. So we're going to take a look at these. Now, what would happen if I cancel? If I cancel the x's, I'm going to get 3x squared. So that's like taking negative infinity and plugging it in for x. So if I take a negative infinity and square it, I'm going to get a positive infinity. And 3 times infinity should be infinity. Now, it's a lot easier to memorize or kind of go over the rules. I'm going to show you what it's going to look like in the graph, because sometimes it's kind of hard to see in the graph, which is why we have these rules. Believe it or not, sometimes it's easier to do it algebraically. So let's take a look. I'm going to plug it in the graph. You can always use the graph and the table to help you. But again, sometimes it's hard to see. Okay. Now, from my graph, it looks like the answer should be negative infinity, right? Let's look at our table. Control T. So negative infinity means my x values are getting smaller. Okay, so those are negative numbers, but all of a sudden it jumps to positive numbers. And guess what? Those positive numbers keep getting bigger and bigger and bigger. Okay, so here's another thing we can do. I'm going to hide the table. Menu, I'm going to zoom. I'm going to do zoom fit. And if you notice, we only saw part of the graph. If I follow that graph to the left, okay, see all the way to the left? It keeps going up. It's not going up very much, but if you notice, my window is really big. So infinity is the correct answer. Okay, let's take a look at the next one. 2x to the 5th on top, x to the 4th on the bottom. Those are the highest powers. Now remember, you got to look for the highest powers. It's not always going to be in order. Okay, if I were to cancel the x's, I would get 2x. And remember, it's going to negative infinity. So I would get a negative 2 times infinity, which is just going to be negative infinity. So this is going to go to negative infinity. And then let's look at the last one, highest power on top, highest power on the bottom, 5x to the 5th, 6x to the 3rd. So if I were to cancel the x's, 5 over 6, x squared. Again, even number is going to make that positive infinity. So basically, if it's an even power after you cancel, it's going to be positive infinity. But if it's an odd power after you cancel, it's going to be a negative infinity. Okay, take a look. This is the challenge question. You can use your calculator to help you, but this one is super tricky. So I want you to think about this and see if you can figure it out, and we're going to go over it next class. Bye.